Alright, this is Math 2, Unit 5, Lesson 6, Trapezoids and Kites, looking at some homework help tonight for numbers 2, 6, 7, 11, 18, and 21. Okay, so a couple things we want to remember about trapezoids. First of all, if it's an isosceles trapezoid, is that we have a lot of congruent parts here. Okay, so our angles that are across from each other this way along the bases are going to be congruent. So angle 2 is going to equal angle 3, just as angle 1 will end up equaling angle, this one here, which is 58 degrees. The other thing that's important for us to remember is that they also become supplementary when you go up and down this way along the bases. Meaning the sums of this and this will be 180 degrees. Comes in handy when you're trying to prove things later on. You'll probably want to know what that theorem is going to be that makes that so. When we look at number 2 to begin with, it wants us to identify the angle measurements for angle 1, 2, and 3. I know initially right away that the measurement of angle 1 is going to be equal to 109 degrees. That's somewhat a given because it's right across from here along that base, that parallel line. This angle will always equal that angle. Now, knowing that these two angles are going to form a supplementary angle when they're combined together, I can take 180 and I can subtract what I know, 109, and I'm left with 71 degrees for the value of angle 3. So the measurement of angle 3 will be 71 degrees. Similarly, because these are opposite each other here on the bases, and it's an isosceles trapezoid, the measurement of angle 2 will also be 71 degrees. So I knew that because of the supplementary portion here is how I solved that. So use what you do know to find out what's a given and then solve for what's missing. The next type of problem we have today is finding this middle value of a trapezoid here. There's a couple ways of setting up this equation. I'll show you the way I prefer. What I saw a lot of in classes as I walked around was to add the top and the bottom and divide by 2 and then make it equal to the middle portion. I prefer myself to set it up this way. I like to do 2x minus 1 plus the top value plus the bottom value. I like to set it equal to, and then do with the distributive property, I put my 2 on this side, 2 times the middle value, 3x minus 6. And that's just me because I really dislike fractions, just like most kids do. So I'd rather not have a fraction over there. So I'm going to, instead of having divided by 2 here, I just put my 2 over there because that's what I would do anyways as the next step. What I'm basically saying is that if I double this value times 2, it'll be equal to the sum of those two values. Now, I can go ahead and combine some like terms on this side, distributive property here. So negative 1 and 25 leaves me on this side with 2x plus 24 equals distributive property, 2 times 3x is 6x, and then 2 times a negative 6 is a negative 12. So let's go ahead and move our negative 2x over here. So we subtract 2x, and we end up with a 4x over there. And I can take my 12 and add a 12 over there, and that's going to equal 36. Divide both sides by 4, and x equals 9. Now, I'm not done yet because it wanted me to, it said, to find GH. Well, GH is not 9. GH is 3x minus 6. So I need to go ahead and write 3x minus 6 and then plug the value of x into that space right there. So if x is really equal to 9, then we get 9 times 3 is 27 minus 6, which gives me its answer of 21 for number 6. Let's take a look at number 7. Number 7, again, these angles here, because an isosceles trapezoid, will be equal to each other. So essentially, all I have to do is say 117 equals 3n. I divide both sides by 3 and discover that n equals 39. I do the same type of thing here, and then here they give you two values here, and they're going to be equal to each other. Let's look at one more of these mid-segments here. I have number 11, where it tells me that I have the top, I'm going to write off this side again, x plus the bottom, 4x minus 2, and again, the way I do it, I set it equal to 2 times 2x plus 1. So when I do my combining, x plus 4x is 5x minus 2, distribute here, equals 4x plus 2. I'll subtract 4x from both sides to end up with an x on this side. That goes away. I'll go ahead and add 2 to both sides, and for x will equal 4. Do I know the length yet? Nope, I don't, because I need to plug that back into my middle equation of 2x plus 1. So I take the 4, stick it in there. 2 times 4 plus 1 gives me 2 plus 4 is 8, plus 1 is 9 for my answer for number 11. Alright, let's turn the page here, and we're going to turn the back side, which is focused on kites. When you're looking at a kite problem, remember that it's not the same as what we looked at before. A kite means you have a set of congruent lines on one portion and another set of congruent lines on the other portion. So it's not going to be quite the same. Now, when they do put the diagonal lines, you still end up with a 90-degree angle. There are perpendicular angle measurements in the middle of the kites. Let's take a look at number 18, because that looks like to me to be the most complicated of all of these. And I think one of the things kids say often is, oh, you showed us the easy ones. What about the hard ones? So let's break this down here. Again, you might approach it a different way. It's up to you. What do you see first that you know or want to work on? Okay. So for me, I recognize that I have diagonal lines that form a perpendicular angle in the middle. So I already know that the measurement of angle 1 is going to be equal to 90 degrees. I know that all of these technically are 90 degrees around the middle. And because those are all 90, I can look around and say, well, what do I want to do next? Well, for me, if this is 90, I don't have enough information to figure out 4 and 5 quite yet. I only have one angle measurement. Over here, I have a 90 and a 55, so I could go for angle 3 next if I chose, because I have 2 of the 3. Over here I have 1 of the 3, and over here I have 2 of the 3. So I have a couple choices. I could solve for this space, or I could solve for angle 3. It really doesn't matter which one you want to go for first. It's totally up to you. Okay? Since we know that this is a 3, let's go ahead and do this one here real quick. So I know that I have a 90 plus a 55, and I'm going to go ahead and call this x for now, okay? Plus x is going to equal 180 degrees. Okay, you good with that so far? So 90 and a 55 plus whatever that is will equal 180 degrees. Well, 90 plus 55 is 145 plus x equals 180. If I subtract 145 from both sides, I discover that x is going to equal 35. And that's not really x, it's actually the measurement of angle 3 is 35 degrees. So now I have another one. So I've got 2 so far in my equation. If this is 35 degrees, because this is a bisecting line, and I can see that this is an isosceles triangle now, the bases are going to be congruent. So then I also know that the measurement of angle 2 is also 35 degrees. Okay? So we have a 35 here and a 35 there. So I've got this one done, and that one done, and that one done, and I'm left with this 4 and this 5. Again, when I look at this guy, I only have one angle measurement, so it's not going to help me much. But if I can solve for this one, I know that this angle will equal the measurement of angle 4, because again, I have another isosceles triangle here, so those bases will be congruent here and here. So let's go ahead and solve for this. We'll call this y for now. Why? Because we want to. And we're going to say that 90 plus 62 plus y is going to equal 180 degrees for this triangle right there. So 90 plus 62, I get 152 plus y equals 180. I'm going to go ahead and subtract 152, and I'm left with 28 equals y. So this space right here is 28 degrees, which really means that, angle 4, the measurement of angle 4 is going to be 28 degrees there. So I'm moving down. I've got 1, I've got 3, I've got 2, I've got 4. What remains is angle 5. And now, because I know what angle 4 is and that that's 90, I do the same thing again. I take a 90 and I add my 28 degrees. And I have right now 118 degrees. And I know that angle 5 will be the difference between 180 minus 118. And we end up with angle 5 equals 62 degrees. Alright, so we solve for angle 1, we solve for angle 2, angle 3, angle 4, and angle 5. Alright, hope we did that right. It looks pretty right to me, but let's move on to the next one. The last one here we're going to look at is number 21, and again we're trying to solve for the variables x and y. I notice that this is one large triangle right there, which means that the sum of all of these will equal 180 degrees. They all have one variable, which is x, so I can simply set this equal to 38 plus 17x plus 1 plus 3x plus 1 is going to equal 180 degrees. I'll combine my like terms. 17 and 3x makes 20x. 38, 39, 40 plus 40 equals 180. So 20x is going to equal, if I subtract 40 from both sides, 140x, and x will equal 7. So I know the value of x, but I still need to find the value of y. So these two I can set equal to each other because they're opposite angles. So I can say that, let's write right here, 2y equals 17x plus 1. I already discovered the value of x as 7, so I can plug that into my equation and say 2y equals 17 times 7 plus 1. 17 times 7 is not one that I have in the top of my head. So 17 times 7 I multiply with a calculator and get 2y equals 119 plus 1. Continuing on, 2y equals 120. Divide both sides by 2 to discover that y equals 60. And in this case, it's just 60. Alright, so I have my value for x and my value for y, and I've solved for that. Alright, thanks.